Okay, so we're through with the theoretical stuff, and we're now when we start talking about kernels. This is the information that you will need to know to work on the lessons, because you're going to be creating your own spice kernels, your own meta kernels, and so forth. We'll talk about kernel architecture, producing kernels, and using kernels. As Maura said, kernel means spice data file. File containing ancillary data. File containing low-level ancillary data that can be used along with other data in spice-within software to determine higher-level observation geometry parameters of use to scientists and engineers in planning and carrying out space missions and analyzing data return from missions. The kernels in the SPICE system are SPK for spacecraft and planet ephemeris, PCK for planetary constants for natural bodies. These are constants that give orientation and size and shape information. Instrument kernel contains instrument documentation and instrument parameters. C kernel, orientation. C comes from camera matrix. And this is typically orientation of spacecraft and other artificial structures, but it can also be used for natural bodies. E kernel, the event kernel, as Scott said, this is rarely used. Frame kernel, it says reference frame specifications. S-block kernel, spacecraft block correlation data. 2 seconds kernel. Meta kernel, this is something that you will be using and creating. This is a mechanism for aggregating and easily loading a collection of kernel files. Digital shape kernel, this has topography data. And DBK, this is a database mechanism primarily used to support the sequence component of the E-kernel. It has also been used for other purposes, such as a star catalog that SPICE provides. Kernels can be in binary or text form. Binary kernels contain mostly data, some metadata as well, in binary forms. They provide rapid access to large amounts of numeric data. Generally, the need for rapid access in compact representation is the reason that SPICE uses a binary format. Binary kernels are not human readable by most humans. They require the use of toolkit software to examine the data contents. And then text form, plain text files contain only prime characters, ASCII values 32 to 126, human readable text. Text kernels are text PCK, is the most common type of PCK, I-kernel, frames kernel, 2 seconds kernel, S-block kernel, and meta kernel. And the binary kernels are SDK, that's the ephemeris kernel, binary PCK, C-kernel, digital shape kernel, and again, these rarely used kernels, the sequence part of the events kernel and the database kernel. Okay, so text kernel is a plain text file of ASCII data, contains assignments of the form variable name equals value. Text kernel should also contain descriptive comments that describe the assignments. So this is the burden that rests on the kernel creator. These comments are sometimes referred to as metadata. Don't confuse this term metadata with meta kernel, which is described later in the tutorial. So here's an example text kernel. Now, I'm going to talk to this slide, but everything I say is actually present on subsequent slides. So here we have at the very beginning of our kernel what's called an ID word. It says KPL, that's for kernel pool. Text kernels start out with this, KPL, and a slash, and then the kernel type, which might be MK, for example, for meta kernel, PCK, IK, LSK. This sequence of characters has to be the very first sequence of characters in the file. That's the first line of the file in the leftmost column. If it's not present there, it won't be recognized by SPICE. And then we have if we can have arbitrary comments between this and the beginning of data. When we start out with a \begin data token all by itself on the line, that tells SPICE that what follows is a set of keyword equal value data assignments. We've got all these assignments with name on the left-hand side. This is the name of what we call a kernel variable. This is the name that SPICE will use to refer to the data. an operator, which could be equal or plus equal, and then data value on the right-hand side. And so here we've got one name and then a string value. Here we've got a name with the same letters but different case. That's a distinct name. Spice considers these names to be case sensitive, and a new data value, or sorry, different data value associated with this name. And then a vector of values that are numeric. There's new name equals, and we have a left paren, values with an optional plus sign for positive values, commas, these are also optional as separators, and a right parenthesis. And these assignments in this form can be split across multiple lines. You can't split the data values, but you can split between, with a white space occurs, you can split vector value assignments over multiple lines. There has to be at least a left parenthesis, though, on the same line as name and equal sign. Here's another set of numbers. Now we're adding, we have plus equals, as Boris mentioned earlier. We are appending the set of values to the set that was established by this assignment. So this is an append operation. It's adding more values to the set of values associated with the name, this name right here. And here we're appending yet more values. You can see the use of scientific notation. Spice also allows you to use uppercase and lowercase e and uppercase and lowercase d, as in Fortran for double precision values. These values, regardless of whether they're expressed as integers or scientific notation, they're all stored as double precision numbers by Spice. Here is a date value in a special format that is particular to use in text kernels. It starts with an @ sign, and then it has a year, month, and day with no hyphens used as separators and no spaces anywhere in the string. And when Spice sees this @ sign, it knows that what comes next is supposed to be a date. After these assignments, we have a backslash begin text. And we can have an arbitrary amount of comments here. And then we start another data block, backslash begin data, and more keyword equal value assignments, backslash begin text, et cetera, et cetera. One thing to be careful about when you're creating your own files is that this character right here is a backslash, not a forward slash. If this token, this backslash begin data, is not recognized, Spice won't see any data at all. So you're going to have a mysterious case where you create a kernel, it looks right, it seems to have the right information in it, and Spice is acting as though you haven't given it any data. The most common reason for that is that this backslash begin data is not present. And once again, these tokens, begin data and begin text, have to be all by themselves on the line. They don't have to be left justified. Only this item at the top, this ID word, has to be left justified. By the way, although it is useful to have this, Spice will be able to understand the kernel if it's missing, if this ID word is missing. The begin data and begin text markers are essential. Also, at the end of your kernel file, you need to have a hard character return. You need to actually make sure that there's a character return following the last characters that you've typed. Okay. But is this anything? So the text kernel types that are recognized, FK, IK, PCK, SBOC, NK, those are the values that can go here, the ID word. But the terminators for text kernels are line feed for Unix, Linux, Mac, or character return line feed for Windows. The end of line marker is usually not visible when displaying text kernel. It can be visible in text editors, not visible if you're looking, typically at least when you're using a web browser. But it must be present on every line in the text kernel. The maximum line length, including any white space, is 132 characters. And I don't remember whether they say that, but the maximum line length of a character string value on the right-hand side is 80 characters. Well, there is a mechanism for continuing character strings over multiple lines. Okay, so once again, the equal sign is an assignment operator, associates one or more values with a variable name. And if you have two assignments to the same name, either in the same kernel or in multiple kernels, one that occurs last is the one that is going to give the values to the variable name that's on the left-hand side. And Boris mentioned that this overrides whatever assignments have taken place before that. To be clear, whatever assignments have taken place first are completely wiped out. So even if, for example, you assigned 3 values to a name and now you assign one more value with equal sign, well, those remaining 2 values it's not the case that they remain. Everything gets wiped out. You start fresh with whatever you've got on the right-hand side, and that's the only value or values associated with the name. So this has to be used with care. Plus equals is an append operation. And this is normally, or this is almost always what you need to use when you want to make your own name ID associations in a kernel. Okay, for the time tokens that I described, begin with the at symbol, the string will be parsed and converted to an internal double precision representation of the epoch expressed in seconds passage into passing epoch. But there is no time system implied. How can that be? The time system is something that is supplied by the software that consumes this. So if you are writing software that is meant to ingest times this way, it's up to your software to decide what time system these times represent. These symbols, or these tokens, represent different time systems in usage by SPI software. The leaf seconds kernel, these symbols are used to represent the epochs at which leaf seconds end, and these are UTC times. But in other kernels, like the PCK file, or frames kernels, these times are used as ephemeris times, barycentric dynamic time. The time system is imposed by the software that consumes this. This conversion does not mean a leaf seconds kernel. That's why this feature is present. Otherwise, we would just have time strings, which we'll explain later. But in any case, be cautious here when you see these. You need to be aware of what time system the software is assuming those times represent. Variable names. Okay, max of 32 characters. They're case sensitive. Cannot include space, period, comma, parentheses, equal sign, or tab. Actually, this is something we need to check. I don't think the period is a rejected value. It seems to be something we never managed to expunge from the slide. Okay, so anyway, the others are definitely correct. Space, period, comma, parentheses, equal sign, tab are not allowed. Recommendation: do not use the plus sign as the last character. Well, the plus sign is an accepted character in a variable name, but there could be confusion between if you've got a variable that ends in a plus and then you've got an equal sign after it. Well, is the plus part of a plus equal operator, or is it part of the variable name? That's an ambiguity. SPICE considers in that case the plus to belong to the operator, and so you're going to have you're going to be defining a new name that you didn't mean to define. So we recommend you stay away from plus variable names. Variable names do not need to follow the general rules that variable names in programming languages follow. For example, there is no requirement that a letter or underscore be the first character of the variable name. This is the syntax. It's just unique to the SPICE text kernel system. Values, numeric values, can be integer, fixed point, and scientific notation. Strings are enclosed in single quotes. Note that these are single quotes apply regardless of what language version of SPICE you're using. If you're using C, C++, Java, it's still single quotes. And the fact that it's the same quoting style across all the languages means that text kernels are portable across languages. Maximum length, 8 characters on a given line, but there is a need to concatenate multiple string values to allow values exceeding 8 characters. String values can contain any praying ASCII character, including blank. Times are identified by the @ sign. Any of these types can be provided as an n-dimensional vector of values. So you can have strings, numbers, or times, or, okay, come back to that. You could have any of these in a vector, components separated by commas, or white space, but not tabs. So when we say white space, it's just commas or blanks. Instead of white space, you just need blanks when we say white space here. Parentheses are used to close a vector. The string value is contained in single quotes. Values of the vector must all be of the same type. Oh dear, this is not quite right. Okay, it says numeric string or time. Times are translated to numbers by Spice. If it says seconds past 8,000. And so you can actually mix numeric and time values. Amazed that this is still on this slide. Okay. And kernel required reading, just more information about this content. Okay, so here's a little graphic describing an assignment in more detail. We've got on the left-hand side of our assignment is a name of a variable, 32 characters maximum, uppercase recommended. So these are case sensitive, but we don't recommend that you use mixed case or lowercase because it's easy for people to get confused. And if you use all uppercase, the chances of having two variables colliding with each other due to change of case is eliminated. 80 max characters for the right-hand side, not including the single quotes at each end. So you've got a single quote here, and text in the middle. Okay, so this is fixed as well. The list of characters, I believe, did not have a comma. On the right-hand side of the text string consisting of any printing characters, we can have vectors and separated by blanks or by comments. We have scientific notation, and we have dates in this app format. And again, we have line feed and a line terminator for Unix, Linux, and Macs, and character return line feed for DOS users. Okay, binary kernel. Well, we don't have much of a picture for binary kernels. It's lots of non-printing data, interspersed with occasional purposes of ASCII characters, and includes a comment area where descriptive metadata should be placed. Spice kernels should contain comments, descriptive information about the data contained in the file. Comments are also known as metadata. Once again, this is really the job of the kernel creator to put descriptive comments in the file so people will understand what the purpose of the file is and how it's legitimate to use it. A few notes on producing kernels. Okay, so this is something that you'll be doing shortly, as soon as this afternoon or early tomorrow, making your own text kernels. It can be produced using a text editor. It must contain only printing characters. It's easy to accidentally put non-printing characters into a text kernel, so one has to be careful about what text editor you use and what features you use. Tab characters are allowed but highly discouraged. Obviously, if you port a kernel and tab characters, its appearance may change from one system to another. Some editors do insert non-printing characters. Be careful about that. Text kernels must have each line terminated with the end of line indicator. And so this is really essential, and don't forget to insert the end of line indicator on the very last line. Very important. Kernels will not be read properly without this. Now, Fortran Open software will detect and warn you if you try to read a non-native text kernel. By non-native, we mean Windows format kernel on a Linux or Unix machine or vice versa. The other language versions of Spice will just read non-native text kernels without complaining. Binary kernels are made using toolkit utility programs or by using toolkit APIs to your own application program. The Spice does provide API which allow you to write your own binary kernels. how kernels are made and used in the backup section describes this. And we have also the separate making SPK and making CK tutorials. To make kernels available to program, you load this terminology you will hear again and again. Loading kernels means making kernel data available to your program. When you load a text kernel, the file is opened, kernel contents are read into memory, variable names and associated values are stored in a data structure called the kernel pool. So you will hear some references to this. This kernel pool is this data structure that stores whatever you've loaded from your text kernels. It does not refer to data from binary kernels. And then the file is closed. When you load a binary kernel, the file is opened. And for SPK, CK, binary PCK, and DSK, no data are read at all until a read request is made by bit software. So you can open or load a large binary kernel, and it won't take a long time because Spice is not actually doing anything with the data at that point. For practical purposes, the binary file remains open unless specifically unloaded by you. But in fact, binary kernels may be opened and closed as needed because Spice allows you to load a lot more binary kernels than are allowed to be simultaneously opened by most versions of the program. But in any case, as it says here, for practical purposes, you can consider the file to be open when you've loaded it. This is for binary kernels. So how do you load kernels? Well, there's a routine called furnish. You furnish the file to Spice. This is how the calls to furnish appear in the different languages that we support. Best practice, don't hardcode file names. Listen to the metakernel and load the metakernel using furnish. So we've got all the file names that you want to load, all these kernel file names you want to load. And for metakernel, you just have this one call. And if you want to change those file names, you don't have to change your code at all, you just change the metakernel. So it will want you to skip your compilation linking step if you're using Fortran or C. And in any case, you've got less code to change and more code stability. So we highly recommend using metakernels and not just loading a bunch of kernels, naming them individually. Binary kernels, whether or not in native format, they may be read by any of the toolkits. This is accomplished by runtime translation built into toolkit code. Runtime translation does not apply to writing tunes of the kernel. As long as you're reading binary kernels, that is, you're doing some geometric computation using SPK files, C kernels, maybe binary PCKs. It doesn't matter if they were created on a Windows system and you're working on a Macintosh, or you're working on a Windows system and the files were created on a Linux machine. These files are effectively portable across incompatible architectures. Text kernels may be read by any of the CIDL and MATLAB toolkits. So that means text kernels of native or non-native format. And for these, runtime translation is accomplished by toolkit code. But this doesn't work for Fortran toolkits. These toolkits for text kernels only in native format. Okay, metakernels. So metakernel is a file that lists names and locations of a collection of Spice kernels that are used together in the Spice-based application. Loading it causes all the kernels listed in it to be loaded. Using a metakernel makes it easy to manage which Spice files are loaded into the program. You don't need to revise your code. Metakernel is implemented using the Spice text kernel standard. So metakernel itself has the same format that we've already described. When you create metakernels, you already know the rules. The rules that you've just seen are the rules for the format of the metakernel. You use the terms metakernel and furnish kernel synonymously. And here's a sample. You see that the ID word has MK after the slash for metakernel. We have backslash begin data, just like all other text kernels. Anything that's data has to be preceded by, I should say, any data block, because there can be multiple assignments in a data block, have to be preceded by backslash begin data. And then we have the statement kernels underscore to underscore load. This is a kernel variable name. It's standard. It's recognized by Spice. Equal sign, and then on the right-hand side, a parenthesis, and then one or more kernel names. You see the kernel names are present with their path names, so that this kernel, this meta kernel, could be moved around in different parts of your file system, and it would still work because these are absolute paths. You see the file names are character strings. They're enclosed in single quotes. They're separated by commas. These commas are optional. This final closing parenthesis is essential. We also see an example of a continued name here at the bottom. We've got this plus sign here, and this is a syntax that's recognized by Spice. Spice understands when you put this plus sign at the end of a line, a character string, it's part of a kernel file name in this kernel load statement, that what follows is a continuation of this original string. So these two strings are concatenated together internally by Spice and treated as a single qualified file. Okay, so slide. Here's a sample meta kernel for Unix map. You see that there is something that's non-portable here, namely the directory or the paths do use the syntax of whatever the host system is. So if you have a Unix style machine, you've got these forward slashes separated into the directory parts of the path name. And we also have forward slashes here, and we'll see that when we switch to Macintosh, we've got a change. Now, before moving on, we've got these variables that look like environment variables, $, and then kernels. And these are variables that are unique to the Spice system. They're not from the host operating system. They're not defined on the command line. They're not defined in a script. They're defined right here in the kernel file itself. These two keywords, path underscore values and path underscore symbols, associate one of these symbols with an actual string path name. And you could put multiple symbols and multiple corresponding values in these assignments. They occur in parallel. Here there's just one variable and one string. And having made this assignment in path values and path symbols, you can use this association in the kernel's load to substitute a given path for this variable. So if you want to change the path, we just change it right here. Got a little bit less work to do, and it's a little bit less editing to do. And this representation is a little bit more compact. If this is a very long path name, it can be convenient to avoid having very, very long values here, to just have these abbreviations. So once again, these are not operating system environment variables. They're variables that just have the scope of this text string. Okay, so if we're working on a Windows system, then our path names use backslash, and we have backslash in these path names as well, including here where the kernel's variable is separated from the defaulting string by a backslash. Okay, kernel precedence. This is an important point. The order in which Spice kernels are loaded at runtime determines their priority when requests for data are made. For binary kernels, data from a higher priority file can be used in case where two or more files contain data overlapping in time for a given object. So for SPKs, CKs, and binary PCKs, the file load last takes precedence. For GSKs, the use of priority will be specified in API calls, but it's not yet supported in N66 toolkits. So for GSKs, all the data that are loaded contribute to the data that can be used. But through API calls, you can specify that only a subset of the data loaded are to be used. And we'll get into that in much more detail later. But this is very important. It's not at all uncommon for SDKs in particular to have competing data. It's data for the same object at the same time in different files, but the data source could be different, the data quality could be different. You have created and reconstructed, or reconstructed from an earlier time versus improved reconstructed and so forth. There are many ways you can have competing data. In that case, you want to understand how to get the, or which data are going to be used by spies.
So if I have a SDK element that cover a long period, and then I have a specific SDK element for a specific period of more, I input the long period before and the plus the specific period.
Yes.
So I have the data.
Yeah, that's right.
Okay.
Yeah, presuming that the small file for the specific
So
period is
when
the one you prefer to use.
Yeah.
Yes.
So when I have, in this case, I have the coverage of the long period, but with the specific SDK on the.
That's right. The coverage will appear to be present for that long period, but when that short period file is available, if that is
Okay.
exactly. If two or more in text kernels, the possibility of competition also occurs. You can have two different kernels that assign values to the same keyword using the equal operator. And in that case, data values associated with the last loaded occurrence of the keyword are used. All earlier values are replaced with the last loaded values. Orientation data from a binary PCK always supersedes orientation data with the same object obtained from a text PCK, no matter the order in which kernels are loaded. Although we're telling you this, and it is true, we have tried to arrange the binary and text PCK so there is no competition. So although this is the way Spice works, it's usually not necessary to know that. There's usually no competition between binary and text PCKs. Unloading kernels. Okay, well, the unloading kernels is infrequently needed for Fortran or C spice, but it's essential for IC mice and Python spice. If you load data into a program that's using IDL, MATLAB, or Python, because of the way these systems interact with shared logic libraries, kernels that are loaded in the session will stay loaded until the end of the session, unless they're specifically unloaded. If you're using Python through the interpreter, this also applies. Load kernels, your program terminates, but the kernels will remain loaded in the shared object library that has the slice subroutines in it. So the routines take clear and unload can be used to unload kernels containing data you wish to be no longer available to your program. Take clear unloads all kernels and clears the kernel pool. Unload specified kernels. Take clear and unload are only capable of unloading files that have been loaded with routine furnished. It will not unload any files that have been loaded with older load routines, such as SPK LEF or load pool. Sorry. What I said is not quite true. K-clear will clear the kernel pool regardless of how the kernels have been loaded. But unload will only unload binary kernels that have been loaded with furnish. Unloading text kernels with unload will also remove any kernel pool data provided through the kernel pool runtime insertion update APIs, PC pool, PP pool, and PI pool. So I've already said that when you load text kernels, you introduce data into the structure called the kernel pool. There also are these API routines for putting data into the kernel pool. Calling unload will wipe out the kernel pool content, so wipe out data inserted through those routines. Okay, I think that actually we've come to the end of it. There's a lot more information about kernels in the kernel required reading, and of course the required readings for the individual kernel types, SPK, CK, PCK, and DSK. Questions?
I know you guys don't actually write the Python distribution.
Yes.
But is there one of those that it sort of follows with those rules about kind of whether you need to unload the kernels and things like that?
I have not experimented with it, but I think it's almost certainly true that kernels loading will be persistent, because that's really behavior of shared object libraries. But I haven't tried it. You could easily try it yourself and find out quickly.
That, there's a question.
Oh, yes?
Yeah, just a clarification between the kernels and the meta-kernels. So the meta-kernels are the one that actually are, let's say, in which you can add descriptions and metadata and additional information beside what the kernels
The
specifically are.
meta-kernel is a kernel that you create to name the kernels that you want to load, so you can centralize that information in a kernel rather than making individual subroutine calls to do the loads.
Okay.
Meta-kernel is not, the meta in meta-kernel
Right.
is not related to metadata. The metadata actually are supposed to be in each individual kernel. The SDK file is supposed to have, the binary kernels have a structure called a comment area, which we pointed out. The comment, and there is a Spice utility called comment, and also API routines for inserting comments and extracting comments or reading comments. In the lessons, you'll actually use comment to examine the comments that are in an existing SDK file. And when an SDK file is made, the creator of that file should put comments into the comment area. Those comments are the metadata. Those are the data that describe what it takes for a user to understand the data and how the data are supposed to be used. And we'll go into that in more detail. But individual kernels have their own features for storing metadata for those data sets. SDK files can have their own metadata, CK files can have their own metadata, text kernels can, and so forth.
Okay.
So
So the
metadata and
meta-kernels
meta-kernels are two totally separate
separate.
ideas.
Okay.
Separate names, separate ideas, no relationship between them.
Actually, it used to be called mission kernels, right? At some point in time, it used to be called
So-
mission kernels.
Are the meta-kernels actually a kind of a sequence list of kernels that are loaded up?
Yes,
Is a kind of working
yes.
steps kind of?
Yes,
Okay.
if you go back and look at the slide that shows an example meta-kernel, if you look at that slide closely, you'll see that a bunch of file names have been listed. There's a kernels to load statement,
Okay.
and on the right-hand side of that statement.
Yeah, unfortunately, I didn't have it in front of me.
Okay, but if you do, you'll see that. And they're also described in the kernel requirement. And so we'll come back to this again, but that is the mechanism we recommend for loading the kernels, is to create a meta-kernel and then load that meta-kernel, and it will cause all the kernels listed in it to become loaded.
Okay.